Hi, hello, good afternoon, one and all. Welcome to the session. Can you, if anybody is there, can you confirm about audio and video so that we can move on to the session? Please do let me know if everything is clear. Is everything clear, my dear? So let's move on. Here, I have got some points I wanted to tell you, and then later I'll take up some questions. Okay, we'll try to practice some questions on series circuits, that is voltage division rule and KVL, basically. All right, so let's move on. Hi, Kalyani and others. Hi, everyone. So please try to respond so that we can move on to the session very quickly. If the responses are quick, then I can take up the session very quickly. Okay. Right. So in the entire series, I have got in this series I have got around I think 6 sessions. I think so in this series. So in this series, I'm going to take up some questions like on series circuits. Series, I'll be taking DC circuit questions and AC circuit questions. Similarly, parallel circuits also parallel with the DC supply and AC supply. That means what I'll take up here RLC circuits and here also RLC circuits. Here only you'll be having only resistive nature. Here you'll be having only resistive nature. And then combination also, series parallel combination also I'll take up. Series and parallel AC and DC circuits. Series parallel DC and AC combination. And then later I'll take up the applications of series circuits and applications of AC circuit. Not in the session I'm saying, in the series I have got around 6 sessions are there. So in that 6 sessions we are going to discuss applications of series and parallel circuits. And the last session is about the fourth element, like we have three passive elements like resistor, inductor and capacitor. There is a fourth element also, that is, there is that name, that name is there, another different name. It's a combination of resistance and with other parameter. So based on that we have got another element. We will discuss that element in the last session. Okay, so in this session I'm going to cover, series DC circuits. Series DC circuits. Okay, so before moving on to the session, there's a small introduction about myself. My name is Naveen Gollapally. I have 7+ years of experience in teaching. Most of the times I'll be teaching networks, measurements, machines and power systems. All right, now tell me, can we proceed to the session very quickly? Can we proceed? Come on, my dear, and try to share this session with your uh, groups also, with your classmates, so that they will also get benefit. I'll take up some basic points and then later we will move on to the questions. Okay, right, shall we proceed? Right, so let's move on. So we are going to discuss these points in this session. We will be discussing how to solve the voltage, current and power of each and every element in the series connection. How to solve voltage value, how to solve resistance, or how to solve current value or power value at the resistance parameters. Okay, after that we will be understanding about Kirchhoff's voltage law. We will try to find out the, how the voltage across different sources connected in series. What will be the total voltage if the voltage sources are connected in series, or how will be the voltage distribution if the resistance and the voltage source are connected in series. We will see that by using Kirchhoff's law. And So we will discuss during that voltage KVL. We will find out some this parameter also, that is how the voltage, how the applied voltage is going to be divided across each and every resistor so as to satisfy law of conservation of energy. So that is what voltage division rule. So these are the points we are going to cover in this session with the questions. Okay, right. So let's move on. I'm repeating once again. We are going to calculate about voltage parameter, current parameter, and the power parameter, right? And similarly, of course, we will take up how to calculate the resistance also in a series circuit. And later we will discuss about Kirchhoff's voltage law, and then later we will discuss about voltage division rule based on the questions. I have got some questions, we will discuss them. Okay, right. Remember, in the series connection, this point you need to remember. In any configuration, if two elements are in series, then the current must be same. The current must be same. Okay, this is electrical terminology. But you do not know, apart from electrical engineer or electronics engineer, they do not know whether they are connected in series, they are connected in parallel. How can they say? Simply, if any two elements are connected like this, if any two elements are connected like this, let me take up R1, let me take up R2. If their element terminals are connected once, R1 terminal and R2 terminal connected once, then that is said to be series connection. If the element terminals physically connected only once, then that is connected, that is called as series connection. Electrically, how do you call it as series connection? If the current flowing through this resistance and if the current flowing through this resistance is same, definitely you can call it as these two resistors are connected in series. Okay, so the current flowing through this one and the current flowing through this one, if the current flowing through this one and R1 and R2 are same, you can call it as the resistors are said to be in series connection. Okay, he's saying that must be same. Yes, that is fine. But there is another chance also like this. There is another chance also like this. If I have a resistance R1 and if I have a resistance R2 like this, some amount of current I is entering. This I, this I is going to divide, is going to enter at this point, is going to enter at this junction, and some of the current will divide through R1, some of the current will divide through R2. So this current I am calling it as I1 and this current I am calling it as I2. There may be chance of equal current division based on the resistance values. If the resistance are equal, current division is also going to be equal. In this case also there might be chance of getting I1 equal to I2. There might not be, there may be or may not be chance of getting I1 equal to I2 or I1. This is the possibility I am saying. There may be a chance of I1 equal to I2. There may not be, there may be a chance of I1 is not equal to I2. So you cannot call this connection as series connection. Even though you have I1 equal to I2, you cannot call it as series connection. Why? Because he's saying that if any two elements are going to carry the current as same, then we will be calling it as series connection. But you cannot call this as series connection. Okay, because R1 terminal and R2 terminal are here connected once, and R1 terminal here, R2 terminal here, connected here once again. The terminals of R1 and R2 are connected twice, but here only once. So in this way you can distinguish, or you can separately, you can say the difference. Even though the currents are same, but the resistor terminals are connected twice here, but here resistor terminals are connected once. If the resistor terminals are connected once, then this is going to be series connection. If the resistor terminals are connected twice, then you can call it as parallel connection. So in that way you can differentiate. Did you understand this point? Everybody please respond. Rohit, there won't be much difference, but you will be having the phase angles. J notation will be there. Inductive reactance, capacitive reactance comes into picture now. So there definitely definites will be there. Can you confirm about this one? Is this clear about, is this point clear? Is this point clear for everyone? I wanted to say this point. So physically, if the terminals are connected once, then you can simply call it as series connection. Physically, if the terminals are connected twice, two element terminals are connected twice, then that is going to be parallel. So current flow in R1 and R2 will be same here. Here also there might be chance of getting possibility. This possibility is there, but you cannot call this connection as series connection. So that is the point I wanted to say. Is it clear for everyone? All right. Now one more thing I wanted to say here. The polarity of the voltage across the resistor is determined by the current direction. If I have a current direction, like if I have a resistor like this, maybe a resistance of some value. Let us take up some resistance value, R ohms. And now the current is flowing. And now the current is flowing from top. Okay. If the current is entering from the top side or top terminal, then entering terminal will be positive, leaving terminal will be negative. So the voltage polarities across the passive elements are going to be depending upon direction of current. Direction of current. So that is the reason why you see here, current direction is here in this direction. Therefore, entering terminal is positive, leaving terminal is negative. Here the current direction is in this direction. Therefore, entering terminal is positive, leaving terminal is negative. Here the current direction is from bottom to top. Here the current direction is from bottom to top. Okay. So we have got here, see, the entering terminal is going to be, entering terminal is positive and leaving terminal is negative. Okay, so these points you need to remember before you are going to apply KVL in a closed path. You need to be careful with these polarities. Direction of current is going to decide the polarities across the passive elements. Be careful. It is going to be passive elements, not active elements. Let me write that. So resistor are simply passive elements, not active elements. Okay. And next point, we will move on to the next point. You see, the direction of conventional current is in the series circuit in such a way that it leaves from the positive terminal, of the supply and returns to negative terminal of the supply. You see here, positive terminal here, this is a positive terminal, it is leaving from positive terminal and is leaving like this. So entering polarity will be here positive, leaving polarity will be negative. See here, everywhere positive, negative, and the current is coming back and entering it negative terminal. Okay. So from an active element, this voltage source, this is an active element. From an active element, the current always leaves from positive polarity, and the current enters, or current, this whatever the current which is left from the active element, the current will come back to the negative polarity and enters at negative polarity. Okay, so these points you need to remember in general. I am saying before you are going to take up the problems. So that's the reason why I am discussing here. Okay, is this clear, my dear? Now see, the same here, the same question. You see resistance of 10 ohms, 30 ohms, 100 ohms. Resistance of 10 ohms, 30 ohms and 100 ohms. So if they ask you to calculate what is the total resistance offered by these three elements, the 10, 30 and 100, I just remove the voltage source, that's it. So you have to look from AB terminals. If he is asking from AB terminals, you have to look into AB terminals. So if you look into AB terminals, now the current is passing through 10 ohms, 30 ohms, 100 ohms and coming back like this. So the voltage source is pumping a current. While it is pumping a current, this much of opposition you are getting. This much of opposition is offered for the voltage source. So the total resistance is a resistance offered for the voltage source. Total resistance is nothing but, RT is nothing but total opposition offered for the voltage source. for the voltage source, or for the current flow driven by the voltage source. That is also fine. For the current flow, driven by voltage source. Current is driven by voltage source, no? Driven by voltage source. So how much it is? How do you calculate? So simply here R1 plus R2 plus R3. So the total resistance is going to be R1 plus R2 plus R3. So you are going to get it as 10 plus 30 plus 100. So you are going to get it as 140. All right. So this is so simple. I'm starting from very basic, then we'll move on to the question. So try to have some patience. Okay. Right. Now look into this one. Can you tell me what is the answer for this one? Find the total resistance of the series resistors in the figure. Can you tell me what is the total resistance? There are 4 resistors and the 4 resistor values are same. So I can take up 4 as common. So 3.33 kilo. 4 into 3.33 kilo. It will be 4 into 3.33 kilo. So probably 4 3s are 12 and 4 3s are 12. It will be around 13.2. How much? How much you are going to get? Everybody respond, my dear. 4 into 3.3. 4 3s are 12 and 4 3s are 12. So it comes out as 13.2 kilo ohms. Right. Ananya, it is my best suggestion is you can go ahead with the IJ Nagrat. IJ Nagrat and Kotare sir book is better. If you want to solve some more problems, you can go ahead with the PS Bimra. Bimra to solve more problems. Here problems and good theory and good problems are there. And PS Bimra, you can go ahead with the more problems if you want to practice. Okay. All right. So this will be around 13.2 kilo ohms. Now here I wanted to tell you one point. Please see. The first circuit R1 is 30 ohms, R2 is 82 ohms and R3 is 10 ohms. And the second circuit, if you see, 10 ohms, 30 ohms, 82 ohms. What I did is simply, what I did is here, this R3, here it is R3, the first circuit is R3, but I have connected, I just replaced, I just interchanged to say exactly. I just reordered, shuffled. So instead of connecting at the end, I have connected at the beginning. So the total resistance offered in this circuit, is not going to be same. Sorry, is not going to be altered. Is not going to be differ. Is going to be same. So the point here is the total resistance in series connection will not be unaffected by the order in which they are connected. So if the resistors are in series, like 1 ohm, 2 ohm, no issues. You can write 2 ohms and 1 ohm also. 2 ohms and 1 ohm also. Even you have a voltage source also like this. 2 ohm, 1 ohm and a voltage source. You can replace it as 2 ohms here and 1 ohm here. No issues at all because they are connected in series. The current flowing through this resistance and current flowing through this resistance is same. So whether you place a resistor here, you interchange. The opposition offered for the current flow is same. The opposition offered for the current flow is going to be same. Okay. So there's points. So these conclusion observation points you keep a note so that it will be useful while solving the questions. Look at this one. Can you tell me the answer for this one? For the series circuit shown in the figure, find the total resistance. Can you tell me what is the total resistance? Seven plus 4 plus 7 plus 4. So you are going to get it as 14 plus 8. It will be 14 plus 8. It will be 20. 2. 14 plus 8. 22. 22 ohms. Right. Is it 122 or 22? 14 plus 8. 22 only, no? 25. Did I miss any term? 7, 4, 11. 11, 11. 22 only, no? 11 plus 11. 22 only, no? Any term is I missed? Did I miss any term? 7 plus 4 plus 7 plus. Okay, this is 7. I'm so sorry. Right. Thank you. So 25 ohms. Okay. Right. Here the point is, when the elements are connected in series, the total resistance is going to be higher than the highest value in the connection. You see the highest value here, it is 7. In the connection, the highest value is 7 only. So definitely the answer should be greater than 7, no doubt. The total resistance will be always greater than the higher resistance, higher resistor value. Okay, so this point you need to remember. All right. Now, the same circuit I have got. Calculate the resulting source current. He's asking calculate the resulting source current. The current here, positive polarity here, be careful. Positive polarity here, negative polarity here. You see the plate is lengthy and here the plate is small. So current leaves from this terminal. So he's asking this current, calculate the resulting source current and determine the voltage across R2. Where is R2? R2 is here. You know the total resistance around 25. Total resistance as 25 ohms. Now I have a voltage source of E of 50 volts. Now the current will be Is equal to E by RT. So you are going to get 50 divided by 25. You are going to get 2 amperes. So this voltage source is going to deliver 2 amperes. Now the 2 amperes is going to flow through each and every resistor. Here also 2 amperes will flow, positive, negative, polarity you can expect. Here also 2 amperes current will flow, positive, negative. He has given already. Here also 2 amperes current will flow, positive, negative, and comes back as 2 amperes. So whatever the current which is leaving from the source, it is coming back and entering at negative terminal. Okay. Can you tell me what is the voltage drop? Current into resistance, 2 into 4. So that will be 8 volts. Okay. That will be 8 volts. If anybody has doubt, please ask me in between. They are so simple. Let me show you after some time. I'll give you the question, so try to answer them. Now I have a lengthy question here. Altogether, determine the total resistance, determine the source current, determine the voltage across each resistance, find the power supplied by the battery, determine the power dissipated by each resistance, like that he has given, and comment on the whether the total power supplied is equal to power dissipated or not. So the question is here. The diagram is here. So first calculate RT, then calculate source current, then calculate what is that voltage across each resistor. So let's do 3 questions. Can you tell me what is RT here? Total resistance. R1 plus R2 plus R3, 1 plus 3 plus 2. So it will be 6 kilo ohms. Now the second question. What is the source current? E divided by total resistance. Source voltage is 36 divided by 6 kilo. So you are going to get source current as 6 milliamperes. If this is a 6 milliamperes, now tell me what is the voltage across each and every resistor? Voltage drop across each and every resistor. Be careful. Current is flowing in this direction. So positive polarity, negative polarity. Let us assume this as V1. Positive polarity, negative polarity. Let us assume this as V2. positive polarity, negative polarity. So this is going to be V3. So if I take up V1, V1 is going to be IS into R1. So that is 6 milli into R1 is 1 kilo. So you are going to get 6 volts. Next, V2 is going to be 6 milli into 3 kilo. You are going to get 18 volts. V3 is going to be 6 milli current into resistance, 6 milli into 2 kilo. So you are going to get it as 12 volts. So this is a voltage division. There is a voltage division. Is it clear for so far? Is it clear for everyone so far? 6, 8, 12. Okay, done. Now what is other question is asking? The power supplied by the battery. Can you tell me what is the power supplied by the battery? This is my battery. So the power supplied by the battery is going to be voltage into current. 36 volts, and the current is leaving from positive terminals. How much current is leaving? 6 milliamperes is leaving. So the power supplied by battery is voltage into current. Vs into Is. 36 into 6 milli. So how much you are going to get? 192 milli. 3 6 are 18. So this will be 30 into 6 will be 180. So 6 into 6 will be 36. Okay. It will be more than that. So 180 plus 36. It will be 216. Yeah, 216 milli. Do not forget this milli. 216 milliwatts. 216 milliwatts. All right. Okay. Right. Now next question. What is the next question? He's asking, determine the power dissipated by each resistor. Determine the power dissipated by each resistor. Let's see. I am representing here. This is P1. Let us calculate P1. Let us calculate P2. Let us calculate P3. So P1 is going to be power dissipated by the resistor is going to be voltage across the resistance 1 and current through that resistance 1. Or otherwise you can write V1 as current into resistance R1 into Is. So you can write it as Is square into R1. Otherwise you can also write V1 square by R1. Any formula you can use. Voltage into current, the voltage drop across this resistance into current flowing through that resistance, or otherwise current square into resistance, or otherwise V1 square by R1. Anything is okay, fine. Can you tell me what is P1? I have got current, so current is of very easy. So 6 milli whole square into resistance, that is 1 kilo. So 36 micro into 1 kilo. Kilo micro, if it is cancelled, then you will get it as 36 milliwatts. P2 is of here 6 milli whole square into resistance, that is 3 kilo. So again 36 micro into 3 kilo. Kilo micro gets cancelled, you will get milli. So 36 into 3 this is a 90, 3 6 18. So 108 milliwatts. Can you tell me what is P3? 36 micro into 2 kilo. So kilo micro gets cancelled, you will get milli. So 36 into 12, you are going to get it as 72 milliwatts. Now let us check all the power dissipations. 36 milliwatts, 108 milliwatts and 72 milliwatts. The total power dissipation at each and every resistor is total power dissipation. Total power dissipation is how much you are going to get? 36 plus 108 plus 72, all milliwatts. So it will be, I think 260 now? Will it be? Definitely it has to match 260. Power delivered by the source is equal to power dissipated by the resistors, so that it has to satisfy law of conservation of energy. It has to satisfy KVL. The voltage applied must be dropped across each and every resistor. We will check that one also. See here. Voltage drop across R1 is how much? 6 volts. Voltage drop across R2 is how much? 12 volts. Voltage drop across R3 is how much? I've got it as where that 12 volts. Okay, so this is 12, 18 and 6. So 12 plus 6 is 18, 18 plus 18 is going to be 36. The applied voltage is going to be dropped across each and every resistor. So what is the last question is asking? The last question is comment on whether the total power supplied is equal to total power dissipated or not. Yes or no? Is it yes or no? Total power supplied is equal to dissipated or not? How much, my dear? Yeah, total power supplied is equal to dissipated in each and every resistor in that loop or in that circuit. So here is going to satisfy law of conservation of energy. This is what Teligent's theorem says about. This is what Teligent's theorem. All right. So let's look into the KVL. See, KVL, whenever you wanted to write KVL, just give me a second. Algebraic sum of voltages applied or voltage drops, algebraic sum of voltage drops equal to algebraic sum of voltage applied, or simply algebraic sum of voltages. This is in a closed path, altogether. This is in a closed path. So simply algebraic sum of voltages in a closed path equal to 0. A closed path equal to 0, or in a loop equal to 0. So see here, how to check the KVL. Before writing KVL, you should represent polarities across each and every element. So I have a 2 volts voltage source, I have a 6 volts voltage source, I have a 10 volts voltage source. So start from this terminal, move from this terminal. If you move from this terminal, now I am leaving with positive polarity, so plus 2 volts. Next, move from this terminal to this terminal, so I am leaving with positive polarity, so plus 6 volts. Similarly, I am moving from this terminal to this terminal. I am crossing each and every element. When I am crossing from this terminal to this terminal, I left with positive polarity. From this terminal to this terminal, I left with positive polarity. From this terminal to this terminal, I left with positive polarity. I am considering all leaving polarities across each and every element. No issues, you can consider all entering polarities also. Now I left this terminal. Now this terminal, and this is an open circuit, so you have to come back. Alright, so the voltage across these two terminals, let us assume V, or otherwise total voltage ET. If you see, plus 2, plus 6, I am considering each and every leaving polarities. Plus 2, plus 6, plus 10, minus, this is the leaving polarity of this one, so minus ET is equal to 0. So ET is equal to 18 volts. Or otherwise, you can consider negative polarities also. Minus 2, that is entering polarities. Minus 2, minus 6 and minus 10, and then next plus ET equal to 0. So ET is equal to again 18 volts you are going to get. Remember the point, before writing KVL, you should assign polarities across each and every element in that closed path. You have to write KVL in the closed path. Don't think that this is an open path. There is an open path, so you just assume some voltage is there across that open terminals. And consider either all leaving polarities across each and every element, or otherwise consider all entering polarities across each and every element. Any one, either entering polarities or leaving polarities you take up. while writing KVL in a closed path. Okay. Now can you tell me about this one? Already this is fine, already done. But see, I am moving from this terminal. I am moving from this terminal to this terminal. So I left with positive. So positive 4. Next, I am moving from this terminal to this terminal. Each and every element I am taking. So this element I left with negative polarity. So minus 3 volt. Now I am moving from this terminal to this terminal. So I left with negative polarity. So minus 9. Next, here it's an open. So let us take a positive, negative, ET. So leaving polarity is negative. So I finish the closed path. So minus ET is equal to 0. So ET will be, this will be 12. 12, of course, minus 12 plus 12 minus 4, it will be 8. Okay. Of course, minus ET is equal to 8 or ET is equal to minus 8 volts. So minus is at this one and positive is at this one. So be careful. Okay. Be careful with the polarities. Right. So let us see. Can you tell me the answer for this one? Can you tell me the answer for this one? Determine the unknown voltage for the circuit shown in the figure. It's actually for the circuit shown in the figure. Unknown voltage. Where is unknown voltage? We know the voltage drop across R1. We know the voltage drop across R2. We know the voltage drop across R3 also. The only unknown is this one. Can you tell me what is Vx? Can you tell me what is Vx? How do you do? Apply KVL simply. Remember, while you are writing KVL, select a closed path in which less elements are there. So I am selecting this closed path. So wherever I started, that point I have to reach. So that will be closed. So this will be plus 32 minus 12. Leaving polarities I am considering. Leaving polarities I am considering. So minus Vx is equal to 0. So Vx is equals to 32 minus 12. You are going to get 20 volts. You can do in another way also. Why are you moving always in the clockwise direction? Why don't you move in anti-clockwise direction? You can move in anti-clockwise direction also, no issues. No issues. So let me take up KVL in this way and anti-clockwise direction. You can go ahead. So if you go ahead in the anti-clockwise direction, plus 14 and plus 6 minus Vx is equal to 0. Also this is plus 6 and minus Vx. Yeah, minus Vx is equal, so Vx is equal to 20 volts. Okay, this is clear for everyone so far? Clear, my dear? Respond. So can you hear me? This one, power gone. So I'm so sorry, power gone. So can you find out, is audio is clear? There is a power cut. Audio is clear. Is audio is clear? Respond, my dear. If audio is clear, please let me know the answer. Yeah, fine. So power cut is there. So there is a power cut. So I'm so sorry. See this one. Using Kirchhoff's voltage law, determine V1 and V2. Can you tell me what is V1? Can you tell me what is V1? You select any one point. Either you can move from A like this, or otherwise you can move from minus V1 terminal and like that. You select any one point and you come back to that. That's it. Okay. You select any one point. Either you move from A and come back, or you move from positive terminal and come back. Stop here. or you can start from here and stop here again. You select any one point and come back there. That's it. Okay. Can you tell me what is V1? I am doing like this. Positive V1 minus 25 minus 15 is equal to 0. Positive V1 minus 25 minus 15 is equal to 0. So V1 is equals to how much? We are going to get 40 volts. Everybody has got the answer? Very good. Kalyani. Others also please do respond, my dear. Others also please do respond. Next, V2. You can check in V2 in clockwise direction. Minus 20 and minus V2 is equal to 0. Okay, you write like this. No need to be in the given direction. You can go in any one direction. No issues. Okay, this is loop 1. I just moved in anti-clockwise direction. Loop 2. I just moved in clockwise direction. You move any one direction according to the given direction or according to your direction you can go. But be careful. Do not be careful with the polarities. So minus 20 minus V2 is equal to 0. So V2 is equal to minus 20. Alright. Everybody, please everybody respond, my dear. This is a very basic session. Okay. So I have got some questions. Let's make it very quick. Determine Vx. Can you tell me what is Vx? Where is Vx? Vx is here. Chalo. Start from somewhere. I am starting from B terminal. I am moving in anti-clockwise direction. So the polarities here is not given. You take up any polarities. A is with positive polarity. B is with negative polarity. Okay. So plus Vx plus 14 plus 6 minus 2 is equal to 0. Yes or no? So let us assume plus minus. So it will be plus Vx plus 14 plus 6 minus 2 is equal to 0. So Vx is equals to 20 minus 2. It will be 18. So minus 18. If you take B as positive, and A as negative, then you will get Vx as 18 volts. So it depends upon the polarity you are going to assume. Depends upon the polarity you are going to assume. If not mentioned, so anyone can be the answer. If not mentioned, anyone can be the answer. Plus 18 or minus 18 can be the answer. Very good. Okay. Now let's move on to this one. Voltage division rule. Using the voltage division rule, determine V1 and V2. To find V1, I need to calculate current. To find V2, I need to calculate current. So the current flowing through 4 ohms, this is just a terminal. There is no current division at all. So whatever the current which is flowing through 4 ohms, the same current also flows through 2 ohms. This circuit is actually going to be look like this actually. 4 ohms, 2 ohms, and here it is grounded now. And this is positive. Positive 24 means like this. You are going to have positive, negative like this. So this is how the circuit looks like. Now in this circuit there will be a current flow I. Both are going to carry the same current. So definitely they are said to be in series connection. Alright. Now let me make this as V1, V2. If you wanted to calculate V1, you need to calculate I, current into 4 ohms. What is the current? Current can be calculated by calculating total resistance. So I know total resistance as 4 plus 2. The current is going to be I is equal to E divided by total resistance. 24 by 6. You are going to get I is equals to 4 amperes. If I is 4 amperes, then it will be 4 into 4, 16. V2, I into 2. So it will be 4 into 2, 8 volts. Okay. So if you wanted to take up voltage division rule, I'll tell you how it is going to be. Is this clear so far? Can you respond? Is this clear so far? Everybody, please respond, my dear. Is this clear so far? So that we can move on. Right. So I got power. Then let me take up this. Right. Now I am going to give the voltage division rule. I'll show you. So V1 can be written as current flowing through that R1 into R1. V2 can be taken as current flowing through that R2 into R2. What is this I? I is the current which is delivered by voltage source. So I have got it as E divided by total resistance into R1. So we write like this, when you want any voltage drop, when you want any resistance voltage drop, supply voltage into E into that resistance divided by total resistance. This is what we did now. E divided by RT, you will get current only. That is what we did in the previous here. E divided by RT. E divided by RT we did, and we got current into resistance. So voltage division rule. Okay. So E divided by RT. So otherwise you can do supply voltage is 24 into 4 divided by total resistance is 4 plus 2, 6. 6 4s are 24, 4 4s are 16. You'll get the same. Similarly here also, either this one or supply voltage into that resistance divided by total resistance. So supply voltage 24 into resistance R2 is 2 and RT is 6. They are going to get as 8 volts. Okay. So this is the voltage division rule. You are going to use voltage division rule. So let it be any number of resistance. Supply voltage into that resistance divided by total resistance. Okay. Clear for everyone? Is it clear for everyone, my dear? Respond, my dear, respond. So that we can move on. Right. So let's move on. Let's move on to the next question. These statements. Please look into the statements. Observe these statements. In the series resistive circuit, the larger the resistance, the more of the applied voltage will capture. You see in the previous one, here is my 4 ohms and here is my 2 ohms. 4 ohms has captured 16 volts of voltage drop. Out of 24 volts is the supply voltage. Out of 24 volts, the highest resistance is going to capture highest voltage. The least resistance is going to capture least voltage. According to their ratios, if the resistance value is more, it can capture more voltage. If the resistance value is less, it can capture less voltage. So that is a point you need to understand. So the ratio, otherwise the ratio of the voltage across series resistor will be same as the ratio of their resistance levels. Higher resistance, higher voltage capture. It will capture higher voltage. Lesser resistance, it will capture lesser voltage drop. Okay. So this point you need to remember. Can you tell me, determine VB and VAB for the network? Can you tell me what is VB? If you wanted to calculate VB, you should know the voltage across R1, that is VAB. 10 volts I know, so plus 10 minus VAB minus VB equal to 0. I want VB. So 10 minus VAB is equal to VB. But what is VAB? What is VAB? VAB is going to be, this voltage source is going to drive a current, and that current flows through R1 and the current flows also through R2 and also through R3. So if you are able to calculate I, then you can calculate voltage drop across R1. Can you tell me what is I? 10 divided by total resistance, that is 2 plus 3 plus 5. So it will be 10 of 1 ampere. So therefore voltage across AB terminal is going to be 1 into 2, 2 volts. VAB is 2 volts. Now what is a VB? Can you tell me what is VB? Plus, I'm moving like this, I'm moving from this one. So plus 10 minus, leaving polarities minus 2, leaving polarities minus VB is equal to 0. So VB is equals to 8 volts. Is it clear for everyone? 2 and 8. Come on, my dear, respond. Is this clear for everyone? VB is 8 volts. VAB is just 2 volts. Okay. VAB is 2 volts and VB is 8 volts and VAB is 2 volts. Right. Now can you tell me about V1 and V2? Can you tell me about V1 and V2? See, select any closed path which should have less number of minimum unknowns. Less number of unknowns. So you have to write a KVL, right? So minus 6, minus 22, minus V1 plus 36. This is a closed path where you can calculate easily V1. Okay. Can you tell me what is V1 now? No need to be in always, no need to be in clockwise. You wanted to move in anti-clockwise, you can move in anti-clockwise also, no issues. So loop 1, let me write plus V1, leaving polarities. I am considering V1, leaving polarities. Here also leaving polarity, here also leaving polarity. So plus 22 plus 6 minus 36. Leaving polarity minus 36 is equal to 0. So V1 is equals to 22 plus 6, 28, 28 minus 36. You are going to get it as around 8. V1 is 8 volts. Can you tell me what is V2? Can you tell me what is V2? You select a closed path where minimum number of unknowns are there. So let me go ahead like this. Plus 12 plus V2 and do like this. Come back like this. Only 3 elements finished. Otherwise, if you move outside now, you have to take up this one and this one and this one you have to take up. You better go ahead this one. Loop 2. So minimum number of elements, easy. Answer will be easy. So and see that the loop should have less number of unknowns. So plus 12 plus V2 minus V1 is equal to 0. So V2 is equals to, V1 is how much? 8. 8 minus 12. So we are going to get it as minus 4 volts. Is it minus 4 V1? Sorry, V2? Or is it 20? V2 is 20. Let's check. Let's check once again. Plus V1 plus 22 plus 6 minus 36. So how much it is? 28 minus 36. It will be 8. So this is minus 8. So V1 is equal to 8. If V1 is equal to 8, then this will be plus 12 plus V2 minus V1 is equal to 0. So plus 12 plus V2. What is V2? We need to calculate. What is V1? That is 8. V1 is 8 now. So V1 is 8. So V2 is equal to, send out to the right side, plus 8 minus 12. So that will be minus 4 only. 12 minus 8, it will be 4 only. Minus 4 only. Na? Please tell me, any mistake is there? Please tell me. Respond, my dear, respond. V2 is equal to V1 minus 12. V1 is 8 minus 12. So you are going to get minus 4. Right. That's one. Determine VAB. Can you tell me VAB? What is the answer? Determine VAB. Can you tell me what is VAB? When he has given VAB, A minus B. So VA is at higher potential and VB is at lower potential. So you can take up positive and you can take up it as negative. Tell me, what is VAB? Plus VAB plus 12, all leaving polarities, minus 18 plus 6 minus 12 is equal to 0. So VAB is equal to plus 12 minus 12 gets cancelled, 18 minus 18 plus 6, it will be minus 12. So you are going to get 12 volts. Is it so, everybody? Superb. Kalyani, superb. Others also please do respond, my dear. Now here this voltage source is connected to this network, but it doesn't have any closed path. It doesn't have any closed path. He is asking voltage across AB terminals. Is asking voltage across AB terminals. So you have to move like this. There is no path to come back like this. So that's the reason why even though it is connected, it is not useful. Redundant. We say that redundant. No use of this one. If you have a closed path, then it will influence the voltage. Now can you tell me about this one? Everybody please try to solve. Using Kirchhoff's voltage law, find the unknown voltage of the configuration in figure. We are about to finish. Find the unknown voltage for the configuration in the figure. Where is unknown voltage? Unknown voltage is here and unknown voltage is here. Can you tell me? Select a closed path in which less number of elements are there. You see, if you move like this, 24, 10 and like this, you will get a voltage here already because 10 is there. So plus 24 minus 10 is equal to V1. V1 is possible. Okay. So loop 1. Plus 24 minus 10. I am considering all leaving polarities. You can consider all entering polarities also. Minus 10 minus V1 is equal to 0. So V1 is equals to 14 volts. Now can you tell me what is V2? Can you tell me what is V2? You can take up anti-clockwise. If you want, you can take up anti-clockwise. Minus 8 plus V2 minus 10. V2 is equals to 18 volts. So far, is it clear for everyone? Very good, Kalyani. Others also please do respond, my dear. A simple KVL and KCL only. For the network in the figure, determine the voltage. VA, VB, VC, VD. VAB, VCB, VCD and VAD, VCA. Remember just now I said, whenever he is asking about VAB, so VA is at higher potential with respect to B terminal. A is at higher potential with respect to B terminal, like that. Can you tell me VA? VA is nothing but from the ground. From the ground you have to move. From the ground you have to move. Can you tell me what is VA? You need to calculate. Okay. So VA is here. A point is here. So from the ground if you move, the potential from the ground to this terminal VA. So this is the voltage across these two only. So you'll come to know. Okay, let me show you. Let me show you. If you have any doubt, let me show you. I am taking A terminal like this. So this is my A terminal that is at higher potential with respect to ground. So let us assume this as VA. So plus VA plus 8 minus 14 is equal to 0. That's it. That is a VA. So VA is going to be loop 1, everybody. Plus VA, I am considering leaving polarities, plus 8 minus 14 is equal to 0. So VA is equals to 8 minus 14, it will be around 6. Yeah, 6. 6 volts. Is it clear? How do you calculate VA? Similarly, VB also. Can you tell me what is VB now? Raju is saying 18. How it is 18? Is anybody has a doubt for about VA? Anybody has a doubt for about VA? So simply bring the terminal and measure with respect to ground. Measure with respect to ground. So from the ground to the terminal VA. So plus VA plus 8 minus 14 is equal to 0. That's a loop. So you are going to get plus 8 minus 14, that will be around 6. Is that clear for everybody? Please tell me, is that clear for everybody? You are saying about other one. Okay, VA. So let's see. Next, VB. Can you tell me what is VB? From the ground, VB is nothing but from the ground you have to select. From the ground. So from the ground, if you move to the B terminal, what is this? I am leaving with positive polarity plus 14. Let me show you otherwise. From the ground to the B terminal, what is there? Like this. So B terminal, extend the B terminal, draw the B terminal like this. So plus minus. This is VB. So what is this? 14, positive, negative. You write KVL. You write KVL. Plus VB minus 14 is equal to 0. Plus VB minus 14 is equal to 0. So VB is equal to 14 volts. Can you tell me what is VC? Can you tell me what is VC? From the ground, you have to move like this, either like this, or otherwise from the ground plus 14 and the voltage drop across 10 ohms, or otherwise minus 6 and the voltage drop across 10. That will give you C. So you have to know the current flowing through this 10 ohm resistance. You have to find out the current flowing through this 10 ohm resistance. So how do you find out current flowing through 10 ohm resistance? How do you find out the current flowing through 10 ohm resistance? You can find out, you can take up a closed path and you can find out current. Can't you calculate current now? So you are calculating VA and VB. So tell me what is, how much everybody has got VAB? So VC everybody got? Everybody has got VC? Okay, right, fine. So I'm hiding. I need VAB. I need VAB from A to B. From A to B. See, this is a A terminal. This is a B terminal. Okay, VAB. So let's see how to draw. This is A terminal and this is B terminal. So I need VAB. So this is VA and this is VB. So from the ground to the B terminal, I have got it as 14 volts. And here it is, I have got it as minus, like this, 8 volts. So what is the voltage? This is VA, I know already, that is how much I have got, 6. This is VA, I have got already 6. This is 6. I just wanted to calculate only between A and B. Okay, A and B. If you do this one, plus 6 plus 8, it will be 14. 14 minus 14 is equal to 0. In this closed path, it should be 0, obviously. But I want only between A and B, that's it. You take up the ground here, you take up the ground here, you move from VA to VB. So you are going to get VA plus 8 minus VB is equal to 0. So VA minus VB is equal to, you are going to get it as, I think, possibly how much it is? Plus 8 or minus 8 you are getting? Plus VA plus 8 minus VB. So VA minus VB will be, VAB will be minus 8 possibly, I think so. Are you getting minus 8 or not? Is that clear for everyone? Please take up ground here. A potential is higher, B potential is lower. So let me take up this one. So write a loop equation. Plus VA plus 8 minus VB is equal to 0. So VA minus VB is equal to minus 8. VAB is equal to minus 8. A terminal is at negative potential. Simply A terminal is with negative terminal. So negative voltage you are going to get. You'll get definitely negative. VAB. Very good, Kalyani and others. So everybody please solve like that only. Okay. So similarly VCB. What is VCB? C to B. So if you wanted to find out this one, you need to find the current actually. You need to find the current. C to D also. You need to find out the current. So take up a closed path and calculate the current. Okay. So let me add a page here. All right, done. I'm adding a page. This is one resistor and here is one resistor and here I have got one voltage source with negative polarity. So 6 volts here, 14 volts here, I think 10, huh? What is this? Yeah, 10 and 10. Now let us assume some current. Okay, so some current. So let us take up some current. So positive and negative. I am assuming the current is flowing in this direction. So let me write positive, positive. All polarities I have mentioned. So plus 14 minus 10I. Whatever the current which is flowing through this 10, this same current will flow. So minus 10I plus 6 is equal to 0. Alright. So it will be 14 plus 6, 20. 20 is equal to 20I. So I is equals to 1 ampere. So the current flowing through 10 ohm resistor is going to be 1 ampere. Now no doubt this is going to be 10 volts drop here. Here also going to be 10 volts drop. So this terminal, I think possibly this is B and this is C, or probably. Yeah, C. Now VBC is going to be 10 volts. VBC is going to be 10 volts. Now what is the other parameter is asking with respect to D. So with respect to D. What is VCD? Can you tell me what is VCD? VCD minus 6 plus 10. Minus 6 plus 10. So you are going to get it as plus 4 volts. Alright, so this is how you can simply calculate. Okay. So this is the way, sir, and I have some questions I'll give you as homework. So please do this one. Please try this one. Find the unknown resistors for the network. R1 value, R2 value, R3 value, R4 value. Find these unknown values. We have voltage and we have current also, and we know the voltage at this point 48, this point also 12, this point also minus 20. These are with respect to ground. Remember that one. 48 means with respect to ground. 12 means with respect to ground. Okay. So this here is a ground. So be careful. Ground is not at this point. Ground is here. So from the ground point to this point, it is from the ground point to this point, it is 48 volts drop. From the ground to this point, it is 12. So 12 by this current will be, you'll get the voltage. So this is a voltage drop. You know 16 milliamperes. So 16 milliampere is flowing through R1, flowing through R2, flowing through R3 and R4 and coming back like this. So the current through each and every resistance is going to be 16. So 16 into resistance, you will get a voltage drop. You know 16 into R3 is equal to how much? That voltage drop is 12 volts. Alright. 16 into R2, that voltage drop is not 48. Be careful. So that voltage drop is how much? It will be plus 12 plus 48 na. So out of 48 you should remove 12 volts. Be careful. Okay. So try this one, otherwise we'll take up tomorrow. And try this one also. Find the unknown voltage source and resistor for the networks. So this is the unknown voltage source is asking. We have got current. So current you can take up add the voltage sources and take up the current from positive terminal itself. Take up the current direction from positive terminal. It has to leave from positive terminal. Current should leave from positive terminal. So assume like that. So it is simple, simply closed, one single closed path or series circuit only. We have given power also. We know power also. Can't you calculate? You know current. That is current is 2 milliamperes. So we know current and we know power. Can't you calculate resistance? I square into R is equal to P. I square into R is equal to P. So P divided by I square. You do this, you will get the resistance value. So after getting resistance value, you can calculate the unknown voltage also easily. Apply KVL, you can find out unknown voltage also. Okay. All right. So if you get any doubts, if you have any doubts, you can call, you can post your doubts onto the Telegram channel. So that will definitely solve them. So please solve those two homework questions. Very good questions. Okay. We will take up them in the tomorrow session and we'll move on to the parallel session, parallel networks. Tomorrow also parallel networks at 12:30. Please inform with your friends also. We will take up some basic points and some questions. Okay. Series and parallel circuit, you doesn't get much difficult questions. So simple questions. KVL, KCL only. I'll take up, very good questions in series parallel combinations are there, no? So that combination networks I'll take up very good question. We'll see. Okay. Fine. Thank you. Thank you one and all. Have a nice day. Bye bye. See you. If you have any doubts, please let me know. All right. Thank you. Superb, Kalyan. Do that one. Thank you everyone. Have a nice day. Bye bye. See you.